So in this video, we're going to do a dilation, in this case of a triangle, with a scale factor of 3. And the center of dilation for this one is not on the figure. So we had other videos where the dilation was centered at a point that was on the figure. That was in lesson 4.1. But lesson 4.2, we're doing a dilation centered at a point that is not one of the points of the figure, so it's off of that diagram. And if you notice, there's a picture of a flashlight up here. And that flashlight is there because it makes me think of what's going to happen when I do this dilation from the center, in this case of point O. What's going to happen is if I dilate it by a scale factor of 3, not only is the triangle going to get 3 times bigger, meaning that the sides will get 3 times bigger, but it will also end up farther away from point O, and it's going to expand out from point O, sort of like the light expands out from a flashlight. If you think about, if you turn on a flashlight and you put the flashlight really close to like a wall or the table, you will see it creates a very small circle or oval depending on the angle of the flashlight. But when you pull that flashlight back from the table, the figure gets bigger. So the figure or the circle would be bigger if it was farther away from the light source of the flashlight than if the light source of the flashlight was closer to the figure, it would be smaller. And so that's the same kind of idea here. This figure is going to get bigger, but also expand out from this center point and be farther away. So the way that we start this construction is we imagine where this triangle will end up after the dilation happens. And since the dilation is a scale factor of 3, point A is going to end up 3 times as far away from O as it currently is, but it's going to extend out in the same direction that A is from O. So what we're going to do is going to start off by taking our straight edge, lining up O and A, and drawing a long line segment that shows the path A will take as it expands out from point O. And we're going to do the same thing with B. And I'm going to use multiple colors here so that you can follow along. I have a feeling that's not long enough, but let's see. And then I'm also going to do the same thing for point C. So each of these points, you can see when I draw this, you can kind of see the path that each point will take as we dilate this. It will go farther down the line. So let's start off with from O to A. What I'm going to do is measure from O to A and leave evidence of that measuring. So I'm measuring from O to point A, leaving a little mark to show that I've measured that. And once I have measured that, that's one length from O to A. I need it to be 3 times the length. So since that's 1, I will move my compass down the line. That's the second. And then this will be the third. So now this is point A prime, which is now 1, 2, 3 times as far from O as A was originally. And then I just have to do that for each of the other ones. So I'm measuring from O to B. O to B, leave evidence of measuring. And then this needs to be 3 times as far. So I'm going to do this 2 more times. One, 2, 3. This is point B prime up here. And then the last one from O to C. Measuring from O to C, that's 1, 2, hard to see that one, 3. And I was lucky here, I made the line long enough. If I hadn't made the line long enough, I would just have to extend that out. So that's C prime. Once you have all of those points constructed, all you have to do is connect them with your straight edge you have constructed a triangle that is 3 times the size of the original one, centered at a point that is off the original figure.